Have you ever written a Python script and just wondered how that little text file can actually reach out and do things on your computer? Well, that's the magic we're getting into today. We're going to look past the usual stuff and dive into two of Python's most powerful built-in modules, OS and sys. Trust me, getting a grip on these is what turns your code from a cool idea into a real-world tool.
Think about it. Your code is kind of stuck in its own little world. So how do we let it out? How does it actually read a file from your desktop, or listen to commands you type in the terminal, or even just know what kind of computer it's running on? That's the puzzle we're going to solve.
And the solution comes down to these two modules working together. Here's the easiest way to think about it. The OS module gives your script hands, right? It lets it touch and move and change files and folders. The sys module, on the other hand, gives it a brain and a voice. It lets the script understand itself and listen to the instructions you give it.
Okay, let's start with the OS module. This is where your code really gets its hands dirty. It's how your script reaches out of that digital box and starts messing with the actual file system on your machine. This is the secret sauce for any kind of serious automation. So, what can you actually do with it? A ton. You can make new folders, delete old files, rename things, all with a single line of Python. You can ask, hey, where am I running from right now? And os.getCwd will tell you. You can peek inside a folder with os.lister. And this is a big one. You can access environment variables. That's where you store secret stuff like API keys so you don't have to hard code them in your script. Super important.
Now let's talk about a classic mistake. I'm pretty sure we've all done this at some point. You need to build a file path, so you just add the strings together with a slash in the middle. It makes perfect sense, and hey, it even works. Until it totally doesn't.
And here is the professional, much smarter way to do it. You use os.path.join. You just give it the parts, the folder, the file, and it figures out the rest. It's cleaner, it's safer, and it just works. So why is this such a big deal? Well, because your code might run on different computers, and not all computers speak the same language. See, Windows uses a backslash for its file paths, but Mac and Linux, they use a forward slash. If you hard code one or the other, your script is going to break on a different system. os.pathJoin is like a universal translator. It automatically uses the right slash for whatever computer it's on. This is non-negotiable for writing code that works everywhere. All right, so our script has hands, thanks to the OS module. Now it's time to give it a brain and a voice with the sys module. This one is all about self-awareness. It lets your script understand the context it's running in and, well, listen.
You know, you don't always want to have to open your script and change the code just to get it to do something a little different. A much better way is to give it instructions from the outside, from the command line, just like this. Those extra words, hello and world, are what we call arguments. They're the instructions we're passing in.
So how does the script hear those instructions? Well, the magic behind that is something called sys.argv. As soon as you run your script, Python creates this special list called argv, and it stuffs everything you typed on the command line right into it. It's your script's ear to the outside world.
So let's break down what that list actually looks like. The very first thing, at index 0, is always the name of the script itself, script.py. Then the next thing you typed, hello, that's at index 1. And the next one, world, is at index 2. It's that simple. It's just a list of the words you typed in order.
But sys can do way more than just listen. It's like your script's control panel. If something goes wrong, you can hit the big red button with sys.exit to stop everything. If you're having trouble importing another module, you can check sys.path to see exactly where Python is looking for it. You can even check which version of Python is running, which is super useful.
Okay, we've met the individual players. We know what OS does, we know what sys does, but the real magic happens when they work together as a team. So let's look at a real-world example to see this power duo in action.
So here's our goal, something you might actually need to do. We want to write a simple tool that lets a user type in a folder name, and our script will list out all the files inside that folder. Simple, practical, and a perfect job for our two modules.
So check out this workflow. First, the user runs the command. The sys module immediately jumps in, and sys.argv grabs that word documents. Now sys hands that over to the OS module. OS takes documents and first checks, hey, does this folder actually exist using os.path.exists? If it does, great. Then os.lister goes into that folder and grabs a list of all the file names. And finally, the script just prints that list out. See that? It's a perfect handoff. Sys listens and OS acts.
So let's just recap this one more time. It's all about a clear division of labor. Anything to do with the file system,
files, folders, paths, environment variables. That's a job for the OS module. But anything to do with the script itself, command line arguments, exiting the program, how the Python interpreter is behaving, that's all sys. Knowing which tool to grab for the job is what makes you a pro.
Okay, this is cool, but why does this really matter? Because this stuff right here isn't just a neat programming trick. This is a career booster. This is the kind of knowledge that takes you from someone who just messes around with Python to someone who can get hired to use it.
Seriously, go look at job descriptions for DevOps or automation or backend engineering. This is what they're asking for. They need people who can write scripts that interact with the system, that can be automated, that can be run from a command line. In these fields, knowing OS and sys isn't just a nice to have. It is literally the price of admission.
So, what's the next step? Don't just watch this, go build something. Start small, build a little command line tool that organizes your downloads folder, or one that analyzes a log file, or a simple script that backs up an important folder. These little projects aren't just for practice, they're amazing portfolio pieces that tell an employer, hey, I know how to build real tools.
And that really brings us to the final, most important question. You now have the keys. You know how to make Python reach out and interact with the real world. So what are you going to do with it? What's the first tool that you are going to build?